Now, with me today is Marvin. He's representing Elastic. How do we know each other? I mean, CertLV is partnering up with Elastic, and we had a really good discussions over the calls before, and he was also giving a workshop yesterday here, and I heard it was really amazing. With this, Marvin, go ahead.
All right, thanks a lot, BB. Good afternoon, everyone. Afternoon. I like to interact with my audiences, so one or two responses would be nice. At least some hands are waving in the back. Okay, let's get straight into it, right? So my talk is entitled Advanced Threat Hunting, and I'll just talk through how you can leverage AI and machine learning for large-scale log analysis. Now, a lot of you probably have heard of Elastic. Some of you are using Elastic, right? You do know that we deal with data, and we're talking big data, right? So let's look at how we're leveraging AI and machine learning in our workflows. I think BB's done a good job in terms of introducing me, but I'll just go through this again. I'm a principal security architect at Elastic, based out of Stockholm in Sweden, part of the Elastic Global Security Specialist team at Elastic. I love everything security operations and intelligence. Previously with IBM, where I was doing similar work, so I just love everything security. Those are my contact details for those of you that might want to connect. I will be interacting with most of you today, tomorrow, and I think I leave on Friday. Okay, let's get straight into it. This is my rough agenda. I'll start with an intro to threat hunting, and then we're going to look at basically threat hunting and machine learning and how they merge together. I'll give a slight introduction to some of the good things we're doing on security or within security as Elastic, and then I'll close it off with the exciting stuff talking about Gen AI. Hopefully there's going to be time for a Q&A, but that's my agenda. Okay, so just a recap on threat hunting. I did some very interactive, so it's nothing personal if I point at you and ask you a question. But how many people are doing threat hunting in your environments? Right? A few hands. Okay, how many are planning to do threat hunting? Okay, more hands. That's interesting. Let's look at threat hunting, right? What is a hunt? A hunt is basically a search, right? It's a search where you go into your environment, right? But it all starts with telemetry. You're doing a search, and search works on data, right? So you want to be in a place where you've collected as much telemetry as possible, and then you're running these interesting searches on that data. And ideally, being a threat hunter, what you're looking to do is to find out stuff you may have missed in your detection workflows in the sense of protecting your organization from threats. There's a lot of methodologies centered around how you can do threat hunting, but I like to concentrate on the ones that are listed here. The first one is hypothesis-driven investigations. So sometimes you might just sit down and say, hey, we've deployed this new application in our environment. There's a new system that we've deployed and commissioned into production. Could there be malicious stuff going on there? So you create a hypothesis and begin to chase leads to see if your hypothesis is valid, right? It's also a situational type of methodology. The next one, which is also my favorite, is that of intelligence-driven types of threat hunts, right? Classic example, let's say you're a bank in Latvia, Bank A, and then you hear Bank B had a cybersecurity incident, and the steps the attackers took in their environments have been shared. So you just want to understand if your organization has been affected as well. So you're using that intelligence to do your threat hunt. The last one, which is going to be the core focus of my talk, is the data-driven threat hunting, where you've got data, and you're like, hey, I just want to know, is there interesting stuff from a threat point of view that I can glean out of my data? So classic workflow, this is the sweet spot where we want to be. Please focus on the workflow at the bottom. So you want to run queries, you want to automate some of those workflows, do a threat hunt, and essentially you want to find those bad things in your environment, right? There's multiple outcomes to a threat hunt, but personally I think the more you can find bad things, the better, or the more you can educate your detection workflows, the better as well, right? So we really want to resolve those hidden things in our environments. Now, we're talking threat hunting, we're talking machine learning. How does machine learning come into the play? So again, just a recap for those of you that are not well-versed in machine learning or just want a recap. So Wikipedia defines machine learning. I'm not going to go through all the text, but the key part is machine learning is essentially a set of algorithms and statistical methods. And the goal that we want to accomplish is to identify patterns and then also inferences, right? So making use of the data and getting certain information that we may not have used, that we may not have found out had we not used the algorithms or the statistical methods. Now, to use machine learning in your environment, you need to know your data. You also need to know your use case, right? Because machine learning is applied everywhere today. In the security space, we like to focus on what's called anomaly detection. So there's two classes, the unsupervised machine learning and the supervised machine learning. We focus on anomaly detection because usually it works on time series data. When we're collecting our security logs, usually there's a timestamp associated with them, and that's where like anomaly detection falls nicely into the play. So let's focus in on anomaly detection, right? So the whole goal of anomaly detection is you want to bring a sufficient set of data, and then you want to learn certain trends or just the behaviors of that data set over time. But the place you want to get into is where you actually start, first of all, having nice findings, and then also predictions of what's coming up after you do the learning itself. And then based on that prediction and the learnings and the outcomes, you want to operationalize it to create that value for your organization. So just a question, what is abnormal here and why is it abnormal, right? I don't expect an answer from you, but I'm using a data set. So this is an airline website, right? Airline booking platform. And each one of the colors is a disparate airline, right? There's KLM, there's a few, hopefully there's Air Baltic there. But anywho, when you look at this, you can see that we've got a population. And one of the members of this population at some point exhibited a trend that is very unusual from their usual trend, right? So again, that could be possibly an anomaly. Here, what is abnormal, right? Basically, if something changes, its behavior compared to its own history, then that change is anomalous. All right, and then we're going to look at another one, right? So it's a similar data set. We're still looking at airlines, but what is abnormal here? It's multiple airlines. There's a certain trend over time, but there's a certain airline where the data is completely skewed from the rest of the population, right? So if something is drastically different than others within a population, then that entity is anomalous. And then, and what exactly is an anomaly, right? Again, we're tracking behaviors of a data set over time, and we're just trying to see if that data or those entities that we're monitoring skew away from their normal operation at some point. So just visually looking at this, you can tell where the anomaly is. So just to cap it off, there's two types of anomalies, or there's two ways to look at anomalies. The first one is something behaves in an inconsistent way with respect to itself over a given period of time. Then the next one is something, over time, behaves in an inconsistent way compared against similar entities, right? So please just bear in mind these concepts as we go forward into the whole conversation. So before I go any further, just a brief introduction into Elastic Security. A lot of you might know us as ELK, whatever you want to know us as, but there's interesting stuff we're doing in the security space, right? So overall, security is a platform that allows you to do observability for IT ops people to monitor your systems in your environment. You can also monitor your systems from a security viewpoint. We also do search. We're born as a search company. We still are a search company. But the platform also allows you to do AI and machine learning in addition to these workflows. So just expanding on the Elastic Security part of it, we're trying to enable you to collect data. So whatever data source you've got, we want you to bring it into the platform and then operationalize that data, right? And from a security viewpoint, what we want you to do is to detect, analyze, investigate, and find interesting insights in your data, right? And then the last part is obviously we want you to take response actions in that sense. Now, when you look at what we've seen so far, what is threat hunting, what is machine learning, what is Elastic Security? Elastic is that platform you just want to do your threat hunting on, right? Because we collect data, including threat intel data. data from your own environment, right? And what we want to do from a threat hunting point of view is we want that hypothesis to trigger the threat hunting process. We want you to do the investigation and then the resolution on a platform like ours. We've specifically taken a certain step in the security solution where we've introduced a certain rule type. It's called the machine learning rule type. It supports both supervised and unsupervised machine learning, right? And then there's a new rule that we've introduced as well called the new terms rule. So this is where you're looking out for new values in certain fields in your data set. A classic example is maybe for a certain subnet or segment of your environment, you're looking for a MAC address that you've never seen before. It's an indication that someone plugged in something that's never been plugged into your network. Okay, so given those rules, let's look at another best practice before we go now into the use cases of how you can do threat hunting using your data. One last best practice, right? So we're saying machine learning is you building these models to do anomalous detections, which aids in threat hunting. One of the things you just want to do is also think about your data, the data that you're collecting, and then also the pre-processing that you do on the data, so how you're parsing and normalizing that data. We use the Elastic Common Schema on Elastic. If you're using another platform, I'm not here necessarily to sell Elastic, but if you want to do threat hunting with machine learning on whatever platform, a good practice is also just to add the schema to your data as well. Okay, so machine learning. What use cases does it cover from a security viewpoint, right? Generally speaking, you can do anomaly detection at the network level, right? Just to see if there's anomalies in the way certain entities on the network are behaving. You can do anomaly detection on your endpoints. You can be user-centric. You can also focus on application behavior, right? Now, this becomes useful because remember, again, when we're doing threat hunting, you create a hypothesis and then go in your data and do searches that give you answers to the different levels of that hypothesis, right? And machine learning gives you that visual possibility of what is really going on in your environment. So the first use case is that of authentication, right? We do know that in our organizations, we do authenticate to our systems all the time. And it's a lot of data, failed logins, successful logins, logins by regular users, service logins, service account logins, logins via the internet and things like that, right? So an example of a use case that you might just want to implement from an authentication point of view, again, this is where we've normalized the data, assuming you're using the Elastic Common Schema. You want to look for unusual large spikes, for example, in authentication failed events, right? So if your hypothesis is saying there was a brute force attack or maybe credentials were stolen and you just want to figure out if someone is using those credentials in your environment, you could look out for the results of this machine learning job, right? So here I'm just using authentication as an example in terms of how machine learning can be applied here. Let's bring it to the endpoints, Linux and Windows, right? Your laptop runs a lot of services. Our servers run a lot of services. Sometimes it's kind of hard to track, things that we've never seen before, right? Or maybe a certain process making a network connection that we've never seen before, because there's just so much of that happening on a daily basis on our machines. An example that I list here is a machine learning job where you're looking for unusual processes using the network, right? And this could indicate some command and control. It could be an indication of lateral movement, persistence, or even data exfiltration. But the point we're looking at is you don't want to be doing these searches manually, but you want to train the model to understand what is it your processes have been doing in your environment over time, and if they skew away and say connect to a destination IP they've never connected to before, you just want to be notified about that. All right, let's bring it back to the network itself. So you can detect anomalous network activity, and again, we're using that Elastic Common Schema, compatible network logs. Another example that I have here is high count by destination country. Now, some of you might have been in the sessions that were presented in the morning, right? We saw the ESET presentation where they were looking at command and control traffic and how the attackers are spinning up all these botnets and the servers out there on the internet. From a threat hunting point of view, if your hypothesis is focused on, hey, is someone exfiltrating data from my environment, and I suspect the threat hunter is from the R country, We all know it, right? I could look at my machine learning job and say, hey, is there a high count by destination country? Unusual high count. Again, we're talking abnormalities in the data set in that sense. Another very common one is DNS tunneling. And I think this came out in the ESET presentation this morning, those of you that attended it. There was also a mention of DNS tunneling by the presentation from Varis, right, on how they do the active cyber defense approach to their investigations. But you can see that DNS tunneling is still one of the most common vectors that attackers want to use, right, in terms of exfiltrating data. And today, DNS also goes over HTTPS, so it's encrypted, right? So doing this anomaly detection, even if the traffic is encrypted, but just looking at unusual patterns in your DNS traffic using machine learning could be helpful when you're doing that threat hunt, again, if your use case is data exfiltration. One thing that was shown in ESET and Varis's talk again, I kind of felt like they were setting the prelude for my talk, is that of domain generation algorithm detection, right? Attackers love to do evasion. They love to be in control. We know that. When they send malware into our environments, they want the malware to call back home, right? And they don't want to be detected, right? Or they don't want their servers or their location to be detected, so they're constantly changing the domain names or the subdomain names. And basically what they're doing is what's called DGA. It's domain generation algorithm, where they're quickly spinning up new subdomains or new subdomain names, right? And then it makes it super hard for us to keep track of that. But then again, machine learning is amazing because you could track a skew, an anomaly, a one-time event, or if there's a huge, massive change of these domains, the frequency of it, you could also create an anomaly job that makes that detection as easy as possible to detect the domain generation algorithms. Okay. We've also taken a use case-driven approach at Elastic, right? So it's kind of nice to create these jobs one by one. The ones that I was showing you, the authentication, the network, the application, and the endpoint machine learning jobs, those are just examples. There's a link. I'm not so sure it was in the slides. I'm happy to share it with you later on, or you can go on our GitHub. But a lot of the machine learning jobs that we've pre-built on Elastic are actually publicly available, right? So if you want to see the whole collection and categories of these machine learning jobs, you can see that on our GitHub repo or even on our website. So Elastic has gone on to this approach of using Elastic Agent. It's a lightweight data shipper that you use to collect your data. But the other thing that we're doing also is we're using Elastic Agent for use case packs, right? So for example, the DGA detection, that comes as an integration pack. So you just enable it, it goes into your data, and then it begins to look out for DGA detections. The other one is living off the land attacks, right? So living off the land, it was mentioned in the morning talks as well. Living off the land, we know that attackers love to use those services, those binaries we've come to trust on our endpoints, right? Those DLLs that we've come to trust on our endpoints, right? And it's kind of hard to track, the behaviors of these things that we trust over time. And that's where we see a huge application of machine learning, right? So say, for example, you open Outlook, there's a malicious attachment, right? It's Excel. And then suddenly Excel spawns setutil, the certificate generation utility on Windows, and then setutil is calling out to an IP that is in Russia, right? That is unusual behavior, right? But it's using setutil. We trust setutil. So sometimes that could be an indication of something that is malicious, and that's where living off the land comes into the play. There's lateral movement and data exfiltration. I'm not going to go into the nitty-gritty details, but I mean, the goal of me sharing these things is basically just to give you ideas in terms of some of the things that you can do with machine learning. Again, threat hunting, you're running a search, and then you're trying to use your data to create this hypothesis that is going to be dictating the types of searches you're doing on your data. Essentially, you need to use machine learning. You can use machine learning for some of those workflows. So you want to operationalize your data, and we're looking at data science for everyone, right? So If those of you that are really heavy on data science and writing your own models and things like that, you can bring your models to Elastic. But for those of you that say, hey, I'm not a data scientist, but this looks cool and I want to try it out, Elastic has really made it easy for you to get up and running in terms of configuring machine learning jobs and the different categories. Again, I'm around if you want a demo of this later on. Okay, so we've touched on threat hunting. We've touched on machine learning. And we've seen how machine learning can aid the threat hunting workflow, right? By really surfacing things that we may not see with the naked eye or things that we may not easily identify by running manual queries. But there's a new kid in town, right? AI. How many of us are using ChatGPT? At work, personal lives, don't be shy. How many of us are not using ChatGPT or any similar technology? I see 2 hands. All right, I think there's more hands, but I see 2 hands, right? If you're not using AI, try it out at least. It's the future, I think. Okay, so we're at an inflection point, right? When you look at the history of AI, for a long time we've been saying, okay, started out with statistical methods, then there were simple algorithms, then the Bayesian methods came up in the engineering space. Between 1960 and 1970, there was an AI winter, right? We gave up. We said, this thing is not going to fly, right? And then it sort of came out again, right? And then there was unsupervised machine learning, Google with the deep learning and everything. We saw that, okay, maybe this can become a reality. But we've come to this inflection point, right, where we're seeing that ChatGPT is not perfect. There's issues, there's privacy concerns, but this technology is becoming more and more adopted. I wanted to show numbers about the adoption rates in Europe, but this is a technical track, so I don't want to really be at that business level. This I screenshot in the morning, right? It's a simple Google trend, and I looked at ChatGPT, how often Latvians search for ChatGPT. It's quite telling, isn't it? All right, let's start with, that's October last year. People were back at work. The use of ChatGPT or searching for ChatGPT increased. I can see that Latvians love their Christmas as well, right? And I think they also like their Easter weekends, right? And they love their summers. We can already see that. If I pull out the one for Sweden, similar trends as well. But this is telling. It means people are using this at work a lot, right? Because when we're on holiday, we're not really using ChatGPT. When we're back in the office, yeah, maybe your boss shouldn't know, but yeah, that's the reality on the ground. Okay, so how can we incorporate Gen AI into security workflows, right? And I'm still looking at this from an angle of threat hunting, but there's also other workflows that AI is empowering in that sense. Now, we're a data company. We do search. We've jumped on this bandwagon, and we see a lot of opportunities, right, for security investigations and threat hunting workflows as well. So we've created what we call the Elastic AI Assistant. And basically what it does is it looks at the workflows that you do from a SOC perspective. The SOC core functions, for those of you that were in my workshop yesterday, are basically to collect relevant data and then to write detections on that data. And then the output of the detections is alerts. So we want to do that alert triaging workflow. And then alert triaging is supposed to surface the priority alerts, and then we do the investigation, and then we do the response action. Now, the alert summarization or investigation is also a parallel workflow to threat hunting, because you can investigate, or you can do a hypothesis and chase that hypothesis. Essentially, it's also an investigation, right? So with AI, we've said, how can we help SOC folks or the security analyst folks or the investigators to really cut down on those hours that we're spending doing these workflows? So these are the workflows we've come up with: alert summarization, query generation, workflow suggestions, data ingestion help as well, and then also query conversion and agent integration advice. So what does this mean? From an alert summarization point of view, sometimes, let's be honest, alerts fire in our environments, or we receive certain events in our monitoring systems. It's not all the time that we make sense of these events, right? So with AI, you can actually give this context to the AI platform, and then it actually explains, because again, they're being trained on a lot of data, and there's public data as well. And then the query generation is interesting, right? There was a nice presentation in the morning. I think it was Varis as well. where he shared about, when they do these investigations, then they share them with government agencies and they share them with other people. And, in that sense, when you receive a threat report, what you want to do is also run a query in your data to see if you've been impacted by what they've seen, right? But sometimes writing queries takes a lot of time. So why can't you use the AI, why can't you use Gen AI to help you with the query generation as well? Okay. So how are we doing this at Elastic? And I know some of you are already having questions of privacy, safety, the data that I'm saying. Was that a sneeze or a yes? All right, that was a sneeze, right? Okay. All right, cool. So what we've done at Elastic is we've said, hey, people are storing their data on Elastic. It's a lot of data. It's private organization data. And that data from a security viewpoint comprises alerts, logs and events, and then obviously they're trying to onboard the data. There's data quality issues there. It's incident response data. And then also sometimes there's natural language use cases, right? Bring all this context into Elastic, into what we call the AI assistant, and then get out tangible outcomes. At the end of the day, we're looking at efficiency, right? The mean time to respond, the mean time to detect. I've been told there's a mean time to collect, how fast you're collecting your data into your platform, but then also you want to gain that industry insight into attack patterns. What do I mean? The classic scenario in our organizations is we come in for work, there's a lot of alerts, then we need to sift through those alerts one by one. Lucky you if you've got a SOAR platform, right? But sometimes it's not easy to, out of say 100 alerts, how many of these 100 alerts are associated with one attack campaign, right? Sometimes it's not trivial to answer that question, and we're looking at really making use of AI for those workflows. Now, I will be showing a lot of these things in the demo. I still have a bit of time. How is this built in the background, right? So where do I start from? On the left-hand side, maybe? So everything on the left-hand side of LLM of choice is what is happening on Elastic. So essentially, you're bringing your data from your environment, including whatever is happening on Elastic, the results you're getting, the alerts and everything. That is your knowledge base, right? That knowledge base can constitute Elastic-provided content. It can be alerts, it can be your own data as well. But we know, for those of you that are using ChatGPT, that usually the quality of the response from ChatGPT is determined by the quality of the prompt, right? And that's why we have that context window. So what we want to do is save you the time that you're spending doing the prompt engineering, save you the time in terms of saying, hey, is this accurate information that I'm sending to the LLMs, right? And I know some people are like, yeah, I really don't want to send that data to LLMs because it's not safe. Data leaks, I'll address that part in a bit. And then there's a part that's called Esri, right? Esri is the Elasticsearch relevance engine. So Elastic, apart from just being a data store, is a vector database as well, right? And we are a search company. Vector databases are really good at finding relationships that are meaningful in your data sets as well. So we're applying some of that capability. So we're getting your knowledge base or your data. You can pass it through Esri for that relevance, and then pass it to the context window, and then send it to the LLM, right? For those of you that are air-gapped, I will talk into that in a little bit because, yeah, we are also working with air-gapped kinds of environments. And what you want is a relevant response from the LLM itself. So I said LLM of choice, so essentially bring your own LLM. As of today, we support a lot of models. So Amazon Bedrock and all those cloud models, Cloud 3 models and all those, yeah, all the juicy stuff from Amazon Bedrock. We do have a connector for it. We recently introduced the Google Vertex AI into Elastic. You can also use OpenAI. For those of you that are saying, hey, I'm on-prem, I don't have a connection to the internet, or I'm not allowed to make a cloud connection, you can run on-prem LLMs and connect them to Elastic, right? Okay. Demo time. May the gods be with me. All right. I had a bad experience at Elasticon last year, so I hope that doesn't repeat here. But BB's on stage. I think that's good luck, so let's get into it. Okay. All right, I'll just come back to my slides, and let's look at the workflows, right? So we're talking about alert summarization. So let's go into it. Typically, this is what you see on Elastic. For those of you that are security analysts, I know a few people are using Elastic. This is what you see on a typical day, right? Okay, so this is today, a couple of alerts are fired. I don't really know what's going on. You know, the typical workflow is you start going through the individual alerts, you know, and trying to do that alert triage, doing a few queries just to see what's important and what's not important. But how about, so let me just make sure I've got this in another tab. So how about we say, hey, I see today I've got 23 alerts, right? How can I run the AI assistant just to tell me what's going on? Is there something that is an indication of an attack campaign? So we introduced what we call attack discovery, right? I could literally run this and say, all right, it already ran. I ran it before, so I wanted the demo gods to be on my side. But essentially, when you come here, you can click on generate. So what attack discovery is going to do is it's going to go through all those 23 alerts and then try to identify how many of these alerts are associated with a single attack. And if there's 2 or 3 attacks, it will say, hey, out of those 23, 3 are associated with one attack, the other 5 with another attack, and the other 10, yeah, maybe they're just miscellaneous alerts, right? So I ran this already. I could run it again, but there's no point in doing that. But then also observe one thing, right? I could use any LLM of my choice because I've done the connection. So if I'm not happy with the results from OpenAI, I can use Mistral if I've deployed it on-prem. I can use Amazon Bedrock or Google Gemini in that sense, right? So what I used for this demo purpose was Azure OpenAI. But again, you can use your own LLM. Now look at this interesting thing, right? So we had 23 alerts, and what attack discovery is telling me is there's a multi-stage cyber attack detected, right? This is not a threat hunting workflow. We'll come to that in a bit. This is an investigation workflow, right? Alerts are fired, but I want you to understand the logic so you can see how you can also apply it to threat hunting. So I look at those alerts, and what attack discovery has done is it's gone in, I hope people at the back can read, and it said, hey, I've actually discovered a multi-stage cyber attack, right? And it's a sophisticated attack, detected, and it involves multiple stages. Initial access was via phishing, right? And then execution of malware was involved. There was defense evasion, credential access, data exfiltration, and the impact was through ransomware. So we've got a ransomware at play in our environment. But then here come the details, right? So the initial access, literally, because again, let me go back to the slides. This part is important, right? So we're giving the LLM our alerts, logs, and events from our environment. And then it's using the knowledge it's been trained on, you know, to say, hey, usually this sequence of alerts indicates a certain attack campaign, right? So basically that is what's happening here. And this is literally data from my environment. So it's telling me the initial access, the attack began with a phishing email containing a malicious attachment, and because I gave it my data, that is a malicious attachment sent to the user, the admin user, on this host, right? I hope people at the back can see this. I can zoom in if you want. Should I? Okay. I've been told I should. I hope this is better. I've been told Latvians don't say when they're not happy. And then I've been told Latvians also don't say when they're happy. So I'm getting the gist of it. Okay, so I hope now you can see this. So we see that the initial access, yada, yada, it tells me the user. It gives me a chronological order of how the attack happened. And because we do map to the attack framework, MITRE ATT&CK, it also shows me the tactics that are involved, right? So there's an initial access, there's an execution, and problem of doing Zoom, there's an exfiltration as well, right? And we know that this is ransomware. So this is attack discovery. From a threat hunting point of view, we don't investigate alerts generally, right? What we do is we investigate events, right? But if you take the same workflow, using your knowledge base and feed this with your own events, and then say, hey, given these 10 events, is there commonality or is there a common threat scenario given the events that you feed it into? It probably will tell you if it is indeed a threat scenario. Make sense? Are we following? Yeah? Are you doing the Latvian thing again? Okay. All right, cool. Let me just go back into this view. Okay, so now I've seen this. So basically, what it does also is it will show me the alerts. Remember we had 23 alerts initially, and now it's telling me out of those 23, 16 of the alerts, or 20 of the alerts, sorry, are associated with this particular multi-staged attack. So now I know, okay, out of the 23, 20 are actually associated with a real attack. And I can begin to zone in. Again, it's chronological order. I can see where stuff started happening. I can begin to do my incident response in that sense. Okay. Let's go back into the alert view, right? Alert summarization. Quite a very good concept as well. So this is my list of alerts again. So we've gotten away from the attack anatomy thing. What I'm going to do now is, let's start with this machine learning rule, right? So let me just expand this alert view. My screen is dark. I can't really brighten it, so I'm having a struggle seeing this. Okay, so I get this alert. And it's basically detection, large spike in network traffic. Now remember the anomaly detections, right, or abnormalities we looked at in the graphs and everything. So this is one of those rules. It's said, hey, there's suddenly a large spike in your network traffic, and this is very unusual, right? So what I can just do is go back to my alert view. The lights are killing me, right? Okay. Then I can say, I just want to chat, right? Now, notice one thing here. An alert has fired in my environment. I've got context. I can see which IPs were involved and things like that. But I can also optionally choose to give the alert summarization to the AI assistant, and we've created this pre-engineered prompts, right? So for example, the alert summarization. As an expert in security operations and incident response, provide a breakdown of the attached alert and summarize what it might mean for my organization. So I'm giving it context, right, from my own organization. Let's try this. The Wi-Fi was a bit slow during lunch, but I think it's improved a little bit. And there we go, right? So it's telling me, based on the provided context, I'll provide a breakdown of the alert. That's high severity. This is data from my environment. That's the IP. That's the MITRE ATT&CK context. And it keeps on generating more information about that alert itself. And because we're in Latvia, I'll just wait for it to finish, and then I'll do a Latvian thing in the solution itself. But this is pretty neat, right? And if I'm happy with the results that it's giving me, I can literally copy this and then add it into my report. Those of you that were in my workshop yesterday, we touched on case management, where we opened cases, attached alerts and timelines and things like that. Even here, you can do the same, right? So you can see, I can literally say, copy to clipboard. I can say, attach this either to an existing case, or I can even create a new case. Cases on Elastic is a ticketing system in the security solution, because usually security teams love to collaborate, right? So we've created a place where you can collaborate, add evidence, attach files, and things like that, right? Okay, so just a time check. Is that inclusive of the Q&A? No. Okay, so this is for me. Oh my God, I feel good. Okay. All right, so it's told me, like, hey, this alert is concerning this IP, the MITRE ATT&CK mapping, potential impact to your organization. It could mean data exfiltration, reconnaissance, and all those juicy things. Then it says recommended actions. And security analysts love this, right? You can potentially isolate the affected host. You can initiate incident response, so activate that, and yada, yada, investigate network activity, and all those steps, right? And I like to be polite, so I'll say thanks. Give me, and I'll do a typo deliberately, give me the previous response in Latvian. I'm not going to read it, but yeah, I can't read Latvian. But hopefully it makes sense, right? So I'll say, hey, thanks, give me the previous response in Latvian. Bibi, does this make sense?
For now, yes.
Okay. I see your faith labels. Okay. Does it make sense still? Okay. Apraxt. Yeah? Okay. Looks good?
The words are correct.
And the semantics and syntax? It seems correct, right? No, guys, girls. Is this correct or not? I don't want it seems correct, maybe, maybe not. Is this correct? Make sense? The grammar is bad.
I mean, it looks correct from the grammar perspective in Latvian language, but context-driven, yeah, maybe we couldn't be able to check it like from the if it's actually the things that it says actually has happened, right? But from a language perspective, it's okay.
Okay. Yeah, but I mean, we saw it in the English version. The IPs, the usernames, the workstations is actually from our data set, where I can give you a guarantee because I know the data. But I mean, I think this is cool. Those of you that are security analysts, this takes you a long time to do, right? Okay, so we've opened one alert, and we've seen basically that feedback. Again, like I said, we can copy these results, add them to our case, we can copy to whatever external platform and whatnot. The other cool thing is, the reason why I was asking if this is correct, if I can find my cursor. Okay, I'm having a tough time to see here. Okay, the other thing is, if you're not happy with the results, you can ask it to regenerate, or again, you can change the model. The context is still there, but if I'm not happy with what OpenAI is telling me, I can try Mistral, I can try, the cloud, the Gemini Pro, and things like that. Okay. So we've seen that there's a data exfiltration. Let's just have just one more alert, right, that we can also summarize. So let me open this one here and check out the metadata, yada, yada, the risk score. So we see some malware detection alert. Let me also just give this context to the LLM. Again, just the alert summary. And I'm going to ask it to summarize this, right? And again, we'll see the same workflow where it does the summarization of what it's seeing in the context of the alert. Now here I'm using an investigation workflow, but you can do this for threat hunting as well. You're just giving it context. You can give it 10 events and say, hey, are these 10 events related? Is there a correlation? Is this a threat scenario? And again, these things have been trained on a lot of data. Possibly you could get something that is related. Okay, the last thing I just want to do, if this can hurry up, I'll blame it on the Wi-Fi at Cyberchase and not on Elastic, but...
Maybe just the model is slow. Maybe you could generate also the video in case no one wants to read it. You can watch a video, no?
Yeah. Anyway, as it's doing that, you know what I'm going to do? I'll say, hey, are the last 2 alerts related? Again, typos on purpose. So remember, the first one was a huge spike in network traffic, outgoing traffic. And then this one is a malware alert. I just want to see if it started with a malware dropping into my environment, and then suddenly there was a callback and things like that, right? So I'm going to say, try this. And then hopefully it's going to give me, or it's going to identify that the data in the first alert is actually related to the second alert as well, or the first alert in this case. So based on the provided context, it appears that the last 2 alerts are indeed related. Let's analyze them, right? And then it's going to give me all that context in terms of this is what happened, that happened, that happened. And then it's going to refer back to the previous alert that I gave it and say these 2, it's going to literally tell you these 2 are related because of certain artifacts that are related in the 2 alerts. Okay. Next thing I just want to show really quickly is query generation. Now, we did introduce a new language. It's called ESQL, piped language. For those of you that know Splunk SPL, Microsoft Custo Query Language, that piping capability is available on Elastic as well. And there's a workflow for that, right? So we've, again, done the prompt engineering. So let's say I want an ESQL. I'm not here to teach you ESQL, but just the workflow. Let's say I'm doing a threat hunt. Let's say a ransomware campaign has broken out, and I just want to see if I'm impacted, right? So I want to use ESQL. So the pre-prompt is done by Elastic. I'll just say that, and I just want it to check for dark radiation ransomware, right? So just a background as this is running, dark radiation ransomware, again, uses living off the land. Stuff on Linux workloads, it uses bash, basically, to bypass a lot of defensive capabilities in our environments. And then it does a bit of lateral movement, it does a bit of asset discovery, and then goes on to encrypt files that are relevant in our environment, right? So what I'm doing here, again, when I'm doing a threat hunt, I don't have to write my queries from scratch. So if it's an intelligence-driven threat hunt, and I know I'm looking for dark radiation IOCs or observables in my environment, I can just literally say, hey, in ESQL, that prompt has been done by Elastic. Give me queries that can help me to see if I've been impacted by dark radiation itself. So I can just copy this to the clipboard and then run it through my data, paste it in the query pen, and I see if I get interesting results from the data that I have. Last thing I just want to show is the security considerations. Now, one of the things that a lot of people come back to us and say is, I love this technology, but I'm not putting this in my production. I don't want to leak data, right? I don't want these LLMs to be getting my organizational data. We understand. Privacy is of concern. We respect it. So one of the things we've done is we've built in certain capability that allows you to do two things, right? So the first one is, remember I mentioned Elastic Common Schema, our normalization schema, our normalization language, if you want to call it that, right? So once you do the mapping of your data to ECS fields, you can now come here. Before you send any queries, you can choose what fields you want to allow to be sent to the LLMs, right? So number one, which fields in my data set do I want to allow to be sent to these AI platforms? Secondly, you will notice that there's also an anonymization capability. So I can say, I want to send username information because it's relevant to my workflows, but I don't want Marvin or Bernard to be included as the value for user.name. So what we'll send to the LLMs is an anonymized value, right? It could be even 1, 2, 3, 4, 5. So the LLM is not picking my real name, so I'm not leaking any personal information. But when the result comes back to Elastic, we actually do the de-anonymization of that data when it comes into Elastic, right? So yeah, with that, I think I've come to the end of my time. Let me just wrap it up with the slides. I've done the demo. There's more. I did say we introduced ESQL. So ESQL is the new query language in town. Love it. It gives you a lot of possibilities, the piping, a lot of stuff that you can do in the context of the queries. Then we also have Elastic Security Labs, which is our threat research and detection engineering team. They do a lot of malware analysis, a lot of reports on the latest attack campaigns, and then they also contribute to the capabilities we have on Elastic Security. We just released our Global Threat Report yesterday or 2 days ago, so please check it out. Interesting trends influenced a lot by this part of the world as well. So please take some time to read the Global Threat Report, and then obviously we also have a guide to how you can do threat hunting on Elastic as well. With that, I just want to say thank you very much.
Thank you, and let's give a round of applause to Marvin. That was good applause or no Latvian applause? Let's give a good Latvian applause so that the ones in the adjacent room think, what's happening here? Woo! Okay, we do have time for 1 or 2 questions. Let's start with the audience. There we have one question.
Thank you. So the capabilities looked very impressive, but my question is, LLMs are known to hallucinate, so how do you address that?
That's a very good question. So there's 2 ways that we do it. So you will have noticed we don't support all the LLMs that are out there, right? So one of the things that Elastic does is there's a certain set of criteria that we've looked at, and hallucination is one of them. In terms of security use cases as well. There's a reason why we also push to have the Google Gemini as part of the connector, right? But to be honest, hallucinations also are dependent on the context that you give them. Like I said, even when we're using ChatGPT, the response is usually only as good as the prompt that you give it. The more specific you can get, and this is a prompt engineering thing, it's not an Elastic thing, the more specific you can get, the better the results you get from these LLMs. So you might have noticed when I did that last dark radiation ransomware, hey, give me a query that I can use to threat hunt. That was a long prompt. And our engineers spent a lot of time to get it to that level because you really need to be specific if you want to have that level of accuracy. I looked at those queries when I was preparing for this talk, and I was really impressed, right? They're really accurate because, again, the prompt has been engineered to be as accurate as possible. Then the other thing is, the other caveat there is you also need to do your own sanity checks internally. What makes sense for you? What doesn't make sense? Those prompts that I showed, you can also add extra ones onto those ones on Elastic. So you can also define templated prompts that make sense for the type of environment that you have. But always you need a human being to validate these things. I think that's the state everyone is in. No one should promise you that AI is super clean and stuff like that. You still need a bit of human validation, especially if you're going to use this in production.
All right, I always ask a question to my speakers. So when you were showing that you have your platform is able to say, okay, there are events, and it's trying to say how many events belong to the same case. What happens in the case if we are dealing with log file or event poisoning and injection of malicious data in there? Would it be possible to detect, hey, these are the ones that shouldn't belong here, or these seem malicious?
Interesting question. So I'll start with, first of all, how the capability works. You might have noticed when we do the attack discovery, we do it in a chronological order. This happened, followed by this, typical of an attack chain. But then also, similar to the previous question, you also want the analyst to verify. Because remember, we had 20 alerts associated with that attack chain. You just want to verify that stuff is accurate. I think you also need to have the human really validate some of these things. In terms of being alerted on log poisoning, unless you've got detection rules to detect log poisoning, it's a pretty of a tricky use case in that sense, right? You need to have some way of detecting that your logs have been poisoned.
All right. Thank you so much. Let's give a round of applause to Marvin again. Thank you so much.
Thank you. Thanks, BB.
And of course, socks and candy for you.
That means I don't need to do the survey, right? Oh, perfect. Thanks a lot. Thank you. Thank you very much. Thanks.